fantastic MapReduce team, and want to welcome you all to the webinar. Appreciate you all joining us, and I'm very excited to have Martin Hall with us, whose company is doing some really innovative things in creating intuitive, easy-to-use tools to help you generate insights from your data. And he's going to be providing a demonstration of how those tools work with Elastic MapReduce and how they work with other AWS services later in this webinar. But first, I want to start and talk a little bit about some key innovations over the last 3 years that have really helped make big data more accessible and moved it from something that was really only available to a few small, large, innovative tech companies, and has now moved over to something that is really a cost of entry into business for a large number of industries. I'm taking a look. Really, data has become a raw material for any business, on par with capital, people, and labor. There really is no way for you to compete in the market today without the ability to understand how your customers are using your products and be able to deliver services to them that are customized and personalized based on that experience. Well, why is big data hard, though? And really it's getting harder. There's really threefold reasons for that. The first being data volume. There's unconstrained growth. It really goes beyond that, though. There's current systems today that were built to deal with really single box solutions around data that haven't been able to scale. And you're left with now data that you want to dig into, data that you want to deliver insights from, and no ability to dig into that. It's beyond volume. It's really about structure as well. This data is often in log formats. You have event logs and clickstream logs. So data is not in the traditional relational form that systems that have been built previously are made to handle. At the same time, you're dealing with social data, where you have to add in human insights around sentiment, other pieces there. You also have new types of data requirements. You need faster response time. Sampling is no longer good enough because you're dealing with customer data, where every piece is very important. Users are demanding the ability to experiment with data in a very, very fast and inexpensive way. And finally, as the ability to process this data has really been commoditized and become available to companies across the board, the real innovation is happening in the complexity of analytics run on that. So you need the ability to have tools that allow you to really analyze data at a very high level. And what all this is pointing to is the need for tools that are built specifically for dealing with big data. That brings me to the first innovation, which is Apache Hadoop, which has really had the effect of lowering the cost of developing big data distributed systems. And so what really is Hadoop? Well, it's an open source framework that combines two different things that allow you to really deal with data at very large scale. And one of those is a fault-tolerant distributed storage system called HDFS that allows you to spread petabytes of data across commodity hardware in a very redundant, resilient way. And combines that with a technique called MapReduce, which allows you to carry out exhaustive analysis over that data in a very efficient way, really by ensuring that the data is moved as rarely as possible and pushing the algorithms and pushing the applications to the data. Key benefits that come from this. You end up with a very, very affordable solution. No longer is that solution tied to a dollars per terabyte equation. Traditional systems will cost as much as $50,000 per terabyte. And now, rather than making decisions on what data you're going to use based on the cost, you're really making a decision based on the value that data can drive for your organization. It's also proven at scale. So there's multiple petabyte solutions running on thousands of node clusters. And many of these solutions show linear scalability as you add additional nodes to those clusters. And finally, it's very flexible. The data can be stored with or without schema, and schema can be added to those after the fact. So Hadoop allows you to lower the cost of developing a big data system. But how about operating a big data system? Hadoop is very well known as a framework that's very difficult to both build up large clusters, to configure those, and to manage those. Operational overhead becomes very large. But even beyond that, show an example of how Amazon internally deals with really the traffic it sees month to month. And here this graph shows the November traffic that we see at Amazon.com over the last year. And what you'll see is fluctuations daily fluctuations, but also you'll see a very large increase in that demand and that usage as we move towards the holiday season and through Q4. And what this effect ends up having is you see really a 3 to 4x difference in the load that you need, depending on what time of the month and what time of the year we're expressing traffic. So what does this have as far as an effect in building up a cluster that can process the event data generated from these users? We spend a large amount of time determining this red line here, determining what the peak load is going to be, then also adding some kind of buffer above that to ensure we have protection in case it goes above what our capacity planning said. What this in fact does is this. It leaves us with 76% of our data. Over 3/4 of our capacity goes unused during that month. Obviously a huge waste. And beyond that, for smaller companies who don't have the years of data that we have in order to try to do that capacity planning, and really are shooting in the dark trying to determine the amount of capacity they're going to need, they end up really with no way to compete in building up the type of systems that can manage the data they're generating. That brings me to innovation number 2, and that is really what I see as the perfect marriage, which is combining Hadoop with its flexibility and scalability with Amazon Web Services in the cloud and utility computing, specifically with our elastic MapReduce service, which is a managed Hadoop service on top of our cloud. And this does is lower that cost of operating big data systems. So what does that do to our graph that I showed earlier? As you can guess here, it allows us to scale our computational needs for data processing based on the exact load required at any given time. You have the ability to purchase by the hour whatever servers you need and then release those as soon as that need goes away. So let me bring that to Amazon Elastic MapReduce. So along with the ability to scale based on your load, as I mentioned earlier, Hadoop has a lot of challenges in configuring a cluster that's both optimized for the hardware you're using and for the networking, but also with dealing with managing a cluster of nodes. And even beyond that, with customizing that cluster to your given problem. In a traditional on-premise solution, you're building up a single cluster and picking the hardware types and the size that make sense for every problem that your organization is going to deal with. As you move over to the cloud, you have the ability to create those on the fly and really customize your solution to what you're going to use it for. Well, there's challenges there as well, because you need to understand the intricacies of each of those cluster sizes and the hardware types and networking you're using. What Amazon Elastic MapReduce does is reduce that complexity of management. So it handles node provisioning, handles customization, it handles a shutdown of nodes. It tunes Hadoop to your hardware and networking, and as we have a really distinct number of different hardware types, which we've been able to test extensively against, we're able to configure specifically for that configuration. It provides tools for debugging and monitoring of those Hadoop clusters, giving you visibility into exactly what's going on within your deployment and allowing you to optimize those on the fly. It also provides very tight integration with other AWS services. So you're going to get improved performance working with data directly from S3. It's going to automatically reprovision nodes that are struggling or that fail. And it's going to make it very easy to use alternate pricing models like spot instances and RIs to reduce the cost of your deployment. And finally, what we offer is the ability to leverage our significant operational experience. So we've had thousands of customers run over 1 million clusters on Elastic MapReduce over the last year. And we have a team who's fully dedicated to monitoring those clusters, to understanding the typical failures, the typical types of bottlenecks that slow performance, and dealing with those failures by reaching out directly to customers and helping them work through it and optimize their systems. And with the ability to purchase premium support at as low as $50 a month, regardless of your cluster size, it gives you a huge ability to leverage the kind of experience in the field working with this that you would take years and years to build up on your own. After a little bit about the advantage of Elastic MapReduce, let me talk a little bit about the customers who are using EMR today. First example, I look at Razorfish. So Razorfish is a digital advertising agency. And they have a couple of kind of unique challenges based on the business they're in. One thing is they're very seasonal, similar to retail companies, but also because their business is driven by customers. As large customers come in, they can see huge spikes in needs for capacity that are very difficult to project and prepare for. An example of that was a Christmas season several years back when a large big box retailer came to them looking for help with ad targeting. What they found was their infrastructure could not scale with this new customer, and serving those ads was taking over a day turnaround, a completely unacceptable amount of time. So they came to us to help them build a new deployment. Working with them, they were able to launch clusters of 500 to 1,000 nodes at a time, push that ad serving time from over a day to several hours. And here's a quote coming back from them: with no upfront investment in hardware, no hardware procurement delay, and no need to hire additional operational staff, they were able to experience a 500% increase in ROA from a similar campaign a year before. So huge advantages to be able to, one, set up a cluster very quickly, access the hardware needed for that immediately and release it when it's no longer needed, and have someone else really deal with the operational hardships of managing a Hadoop cluster. Second one I want to talk about is Yelp. They use Elastic MapReduce for a large number of features, including the recommendation engine. Things like people who viewed this also viewed this. They also use it for spelling suggestions. So to run through its list of all previous searches as well as what restaurants or hotels they already have in their database, and use that to determine what you're likely searching for. And here's a quote from them: with Elastic MapReduce, our developers can solve problems they couldn't before, and our operation team can focus their energies on other challenges. It's really the power, the ability to access the infrastructure you need, again, without the need to work with a dedicated staff to set up that Hadoop cluster, gives a whole new level of flexibility for experimentation. Decisions that were made in the past based on really months of analysis and determining whether provisioning additional hardware made sense and whether moving staff over to work on it made sense, has now been moved to a single person, being able to come up with an algorithm and run it against 1,000 machines for a small amount of money in a single day. Experimentation and testing is really what drives innovation, and these tools have made that significantly easier for customers. And finally, I'm going to talk about Etsy. Etsy uses Elastic MapReduce for its recommendation engine as well, and also for large amounts of personalization. So Etsy is the world's largest seller of handmade goods. This brings some interesting challenges, because these handmade goods usually come from individual sellers and don't often sell in bulk. They really end up with a long tail of goods for which to deal with and to provide recommendation to customers around. So they do some innovative things like pulling in Facebook data in order to give you suggestions for gifts for friends. They pull that data in, and they also allow you to supplement that with additional information, and then they compare that to their long tail of available goods. They use that using Elastic MapReduce, but the need for that really moves up and down throughout the day, and also a lot of their personalization and recommendation work is done in a batch mode in kind of huge spikes during early portions of the day. So you can see here lower in the slide the total number of machines they use at different periods within a day. But you can see a huge spike. They'll come up to 750, 800 machines, and then drop all the way down to virtually 0 in minutes. Kind of flexibility that is available now with combining the cloud and Hadoop that never would have been possible previously. And lastly, I'm going to talk a little about the internal use of Elastic MapReduce. So Hadoop is hugely important to what Amazon does around a large number of things, including inventory management, personalization, fraud detection, many different pieces we use it for. And you can see it's really just exploded over the recent period of time. And this is really for the same reasons I've given earlier. They have the ability to access the same resources as other customers, have the same ability to take advantage of this experimentation. And it's had more and more teams shifting over to use the power and to generate insights from data that even at a company as innovative as Amazon a few years back were unable to take advantage of. So really what these tools have done is take what was once available only to very large companies, has put it in the hands of really any company out there who is interested in understanding what their data can tell them. So with that, I'm going to talk about the third innovation. So along with lowering the cost of operating these big data systems and these distributed systems, there's a real need for customers to be able to use tools that they already have and skills that they already understand, typically in the graphical space. And that's what combining Elastic MapReduce and Amazon Web Services with tools like Karmasphere has created really allows you to do. You have this new ability to take a graphical tool, to use something like SQL, and immediately be able to dig into petabytes worth of data with an intuitive interface that it takes very little time to learn and adapt to. So with that, I'm going to pass this over to Martin Hall, who will talk a little bit more about Karmasphere in general and show a demo of these pieces all working together.
Well, good morning, everyone. Thank you, Adam. What I want to do this morning is talk a little bit about the relationship between Karmasphere and Amazon, give you a little lay of the land in terms of Karmasphere, the company, but spend the bulk of the time talking about the big data analytics workflow and what it means to work with large amounts of data, whether they're structured or unstructured, with the Karmasphere Analyst product in conjunction with Amazon Elastic MapReduce. We've been working for over 2 years, focused entirely on building products that provide powerful, familiar interfaces for big data professionals to do big data analytics, harnessing things like Hadoop and in particular the power of the cloud. The expertise that is behind what we deliver at Karmasphere comes from a number of different companies and a number of different products and technologies, including Hadoop, analytics, programming languages. But our focus in life really is the big data professional and productivity of that big data professional using skills and the kinds of applications and interfaces that they're familiar with. So our mission really is to enable all of those data professionals, whether they are developers, data scientists, or data analysts, to easily be able to get insights from any amount and any type of data that exists within their business and to transform their businesses with that data. In terms of our relationship with Amazon, we've been working closely with Adam and his colleagues on the Elastic MapReduce team at Amazon for over 2 years now, since they first introduced this powerful Hadoop-based service called Elastic MapReduce. We've created tight integration between our products and their cloud-based services, and we continue to innovate jointly on our technology and product roadmaps. As they move forward with more and more capabilities in the cloud, we move forward marrying more and more features and capabilities in Karmasphere products. So think about sort of the cloud as bringing all of that power of the infrastructure that Adam talked about, all the business enabling capability, and we heard some of the use cases, through applications from Karmasphere that make it easy to access that power for all the data professionals that need to touch, harness, explore, analyze, and then act on the data and insights they get from it. We get asked a lot to explain what this new data fabric looks like. What does it mean if you're sort of injecting Hadoop into your corporate environment? And in particular, what does it mean if you're injecting Hadoop into that environment and you're an Amazon customer today and you want to start to use all the data that you've stored on S3 that continues to be driven into S3 from things like weblogs, machine sensors, backups, running operationally your relational database on Amazon. So really the way to think about Hadoop is sort of it's a two-tier infrastructure. You've got sort of Hadoop, the power of the storage infrastructure, the MapReduce capability, and then you need applications that give your data professionals access to that. Adam gave a little bit of background on Amazon and the cloud, and where the lower part of this diagram is concerned in your data fabric, with your unstructured and structured data, that's typically sitting on the bulk, if not all of it, is sitting in Amazon S3. As Adam mentioned, Elastic MapReduce is the cloud Amazon-based implementation of Hadoop, and we'll talk more about how we provide access to that in a moment. But let's not forget that many companies are running relational databases and data warehouses, and once they've extracted value from their massive amounts of data, they want to do something with that. They want to integrate it with other applications on the desktop or push it into other data stores that they might already have, including things like Amazon RDS. So moving on and into a little more detail on the Karmasphere Analyst product. As I said, this is a front-end product for data professionals. It provides a graphical workspace that runs on the desktop, and it's designed natively to work with big data and big data stored on Amazon S3 in the cloud, and to create and provide those data professionals with a familiar interface so that they can bring SQL skills, and in many cases they don't even need SQL skills because of abstractions and helpers that we provide. But it has tight integration with Amazon's cloud service to the point where, as you'll see in the demonstration, once you enter your Amazon credentials, you start to get access to the power of Amazon Elastic MapReduce to job flows and to using the data you've got on S3 in combination with Hadoop and Elastic MapReduce. And finally, for those people who are on today's webinar who have a little familiarity with the Hadoop ecosystem, things like MapReduce and HDFS, you may have come across an open source project called Hive, which Amazon support in Elastic MapReduce and which we're completely compatible with from the Karmasphere Analyst product. So to talk just a little bit about the specific Amazon services that you can get access to within and from Karmasphere Analyst, the key one is Amazon Elastic MapReduce, but it's not the only one. In order to provide access for general Amazon accounts and for the more recently introduced sort of individualized account system called IAM, you can use that functionality within Karmasphere Analyst. We provide native graphical drag-and-drop browsing access, and you'll see that in my demonstration in a moment, to Amazon S3. And you can push result sets onto Amazon S3 and into Amazon RDS, and I'll talk a little bit about that as we get into the demonstration. So to give you a little bit of the lay of the land in terms of sort of what's happening when you see this demonstration. On the desktop, Karmasphere Analyst is running, and it has access, obviously, to the local file system on the computer it's running and to any of the corporate file systems that are available to it. It's then communicating with Amazon services in the cloud, in particular with Amazon Elastic MapReduce, talking to either existing clusters or job flows or spinning new ones up, and giving you access to all the data that you have stored in Amazon S3. For the purposes of today's demonstration, we're actually going to use 3 different data sets. 2 of those data sets sit on Amazon S3 already. So many companies are running their businesses on the Amazon cloud and are running those businesses off, for example, relational database stores that are sitting in Amazon. So most companies have a relational database store with a certain amount of structured data in it about their customers and their transactions. As well as structured and unstructured data that companies have, we're seeing an increasing move towards third-party public data being valuable to companies so that they can combine not just access to any amount of structured and unstructured data, but to get access to third-party data as well. So I'm sure everyone on this call is familiar with Twitter. There are 1 or 2 companies out there, DataSet in particular, who make that data available to third parties for them to be able to combine it with their own enterprise data and extract value from that combination, and I'll show you some of that this morning. Finally, what we find a lot of is data analysts, data scientists, developers who have their own small data sets that they want to add to the aggregate data that they want to analyze in the cloud. So for the example that we have this morning, we have a small data set of time segments that are stored on the local desktop that we'll push into the Amazon cloud to combine with the other data. So moving on and towards the demonstration itself, what we've found over the past 2 years working with customers is that there are really 4 key steps in doing big data analytics. And we've introduced a workflow into our Karmasphere Analyst product that makes it easy to move through those steps and then focus in on the analysis and acting on the results of the analysis. You have to be able to access one or more clusters in Amazon's cloud. You have to be able to point to all the data that you want to use, whether it's on Amazon S3 or on your local file system. And then you want to be able to get into and really explore the data, to analyze it, to use your existing skill set, to extract those insights that you can then act on within your business. I'm going to walk you through each of the steps this morning. So moving into the demonstration. First of all, what you see here is the Karmasphere Analyst product. This is the home page of the product that gives you your sort of macro view of the workflow, all kinds of resources to help get you going, tutorials, instructional videos, additional sort of quick start guides and answers to questions. But what this principally does is orient you to the workflow itself, the access, assemble, and analyze workflow. And this is what you use in the product to navigate your way through the different stages of the workflow. So if we get into the workflow itself, step one is really all about accessing the Amazon cloud and enabling you to traverse the file systems in Amazon S3 to get access to existing job flows that are running in the context of your account, or to start new job flows, to connect to those job flows, and to begin with, as we'll see, to enter your Amazon account credentials. So within the product, and the access view in particular, a set of toolbar icons give you access to commonly used functions. So whether you want to add a new connection, whether you want to share connections with other people, you can do that. But if you're running in the Amazon cloud, what you really want to start with is adding your Amazon account information. So you give the product information, you'll give the Amazon account a name, and then enter your familiar access and secret access keys. And then in order to get access to information and services in different regions, you can choose the particular SSH key for that region. So at this point, you've told Karmasphere Analyst your security credentials so it can talk to the Amazon cloud. And what you see here immediately is that for any job flows that are already running in the context of your account, they appear automatically in what's called the connections pane. What you can also do, and we find companies who have persistent job flows or Hadoop clusters to which they want to attach and on which they want to run analytics, but in many cases there are individual analysts or teams of analysts who don't want to touch that sort of corporate persistent cluster. They want to run up a new job flow or cluster for an hour two's analytics, only incur the costs for the analytics for that period of time, or run it up for a day, for example. And you can do that within Karmasphere Analyst with what we see here, which is the interface for starting a new job flow. So really the access phase is all about setting up the connections, putting in your account credentials, and allowing to start your connection on the job flow. Moving on to the assemble phase, the assembly phase is all about pointing at the data that you want to analyze, no matter how big that data is, no matter what type of that data is, no matter where it's located. So whether it's on S3, it's on a local or network file system, whether it's structured or unstructured data, whether it's even compressed data. Many companies now are looking to store, for example, their web logs in a compressed format to save space. Karmasphere Analyst can incorporate in the assemble phase access to those data types. And for those people who are familiar with Hive and this notion of metastores, when you are pointing at preparing and assembling your data, the metadata that's being created that describes that data is stored in a metastore, and the product supports both Amazon, local network, and even local computer-based metastores. So moving into a demonstration of the assemble stage of the workflow, once again, the common tasks are available from the toolbar. So you can create a new table, an empty table. You can create a new table from data. You can drop tables. This is all available to you in the table pane. And what we see here is a set of transactions that were already stored in a relational database and already available to me. But if I want to add a new table to the system, then what I can do is use the new table from data capability, and this invokes a wizard. And this wizard has a lot of heuristics behind it that allows me to basically go and point at the location of the data. In this case, the data is already sitting on Amazon S3, and what you're seeing here is us navigating Amazon S3 with the graphical user interface, choosing the data that we want to assemble and prepare for analysis. And then what the product does is, with many data formats, is it understands, for example, with a CSV file, that the first row in some cases is a header row, and it will allow you to auto-populate the names of your columns based on what's in the header row. But what we can also do, and we find this with many customers, that they have smaller data sets that might be sitting in their local network or on their local computer. And in this case, we've got some time segments that an analyst has stored on their local computer, but they want to get that in to the aggregate data set they're going to use for analysis. So in this case, we're going to navigate their local file system, find the particular data that they want to use, choose that data, and then make sure that that gets uploaded to S3. So the wizard, again, allows it to automatically discover the format of many popular data types, and essentially enable you to get that data set up, and if necessary, move the data from your local file system into Amazon S3. So I've shown you some of the capabilities of the assemble phase. What I'm going to do now, once this has just sort of shown you the different tables that are now available for assembly, we're going to move on and look at the analysis phase of the workflow. So in the analyze stage of the workflow, and this is where analysts spend the bulk of their time, you get to analyze all of that data you've prepared in the assemble stage. You can explore it, you can query it, you can visualize it. Most importantly, what we found is that the lingua franca for analysts is SQL. So for everybody who already has some SQL capabilities, no matter how rudimentary, Karmasphere Analyst provides familiar access to that big data using skills they've already got. It provides autocomplete, syntax highlighting, visual query plans, so you can see how particular SQL statements or scripts get translated into MapReduce jobs. You can take advantage of a whole series of functions that are included in the product, extend it with your own. There are a whole bunch of helpers that are intelligent about how to aid you with local processing and on-the-cluster processing, and a set of visualization capabilities that we're going to see in the demonstration here. So moving into the demo of the analyze phase itself, again, the toolbar provides access to common functions, whether it's running a full query, running query on a sample, terminating a query, being able to load and save scripts. You can do all of that. As you saw before, we created these tables that are now sitting in S3. We prepared these things. Now we're in a position to start looking at the data. So there are some helpers here that mean we don't even have to type in some SQL, so I can start to explore the segments data, which basically is just aggregating particular time periods into times of day. And this is going to become useful as we start to look more specifically at the transaction data. So the customer transactions from, in this case, a retail store, and the retail store happens to be a well-known coffee store based in Seattle. And so what you see happening here, you just saw the visual query plan that explains what's going on. We can start to get more sophisticated joins going on, where we're joining the data about our customer transactions with the check-ins that are based on the DataSift data that comes from both Foursquare and Twitter, that shows us what kind of check-ins have there been from customers in this particular retail store. So what we start to do as we go through this is we start to sort of refine our analysis. We've seen some more interesting information about, well, what times of day are most popular. We can combine the demographic data that's contained in the social media data from DataSift and start to get a sense of, well, what's the gender of those customers? What times of day are they checking in? What kind of transactions are going on at the same time? So what we see here is some of the capabilities of the product being able to kind of explore the data results, sort the different columns, and then start to format some of that data. So if I want to to make this sort of data look a little more usable, I can apply some formats to it. So I want to show decimal points, for example, I can do that. Then the filtering, a lot of sort of filtering and sorting capabilities are where, as Adam spoke to earlier, some of the sort of needs to have big data intelligence in your product. So this helper here is showing how to actually further refine the analysis using the power of the cluster. So in this particular case, what we want to do is take our result set and boil it down to only those people, only those particular retail stores where there have been more than a set number of transactions. So what we've seen here really is the sort of ability to combine both structured and unstructured data of any size, incorporate data I might have on my local network, use not just the capabilities of my local system, but take advantage of the facilities within Elastic MapReduce and on the cluster to basically explore, to continue to refine, to iterate, to sort and filter, and get to some insights from the data that we have just utilized. So at that point, what I've learned is, you know what, there's some correlation between the check-ins from people who are tweeting and checking in using Foursquare and the retail stores with the transactions that are occurring. And I want to share some of those results within my business. My product manager, for example, might want to take some of that data and run some experiments with products that were particularly popular at particular times of day for a particular agenda. So the act part of the product delivers the ability to basically share and operationalize not just the queries that you created to gain those insights, but the result sets and visualizations. So you can save results to S3. You can save results in different formats to your local file system, to databases, to Amazon RDS. And as you'll see in the next part of the demonstration, I can also use those result sets in things like Microsoft Excel with a single click. So we move on to this part of the demonstration. Again, all of these capabilities are incorporated within the toolbar. So whether I want to create charts, whether I want to save the data to a CSV or TSV, to a native Microsoft Excel file, push it into a database, push it into another Hadoop open source Hive table, or create charts, I can do all of this. So taking the results that we just created by combining the 3 different data sets, I can use the charting wizard here to look at, well, what were the most popular products based on people who were checking in at the most popular location. So a few quick steps here will lead me to a chart that I can then act on within my business. I can share it with other people. I can save it to, for example, Amazon S3. I can copy it to a clipboard and merge it into my email. So here what we're going to see is, again, this native integration with the Amazon services and being able to choose not just my local or corporate file systems, but any Amazon S3 bucket and save my data using the power of Amazon's S3-based service. And finally, just looking again at some of the formatting capabilities, in many cases, people want to be able to sort of push result sets into another familiar product on the desktop. So whether you take just the native result set or whether you apply formatting to that result set to help with your visualizations, what you can do within the product is not only save those to a native Microsoft Excel file, whether that be on your local file system or on Amazon S3, but you can also click a button on the toolbar and get automatic invocation of that result set within Microsoft Excel. So again, it preserves all the formatting that we've used and created within Karmasphere Analyst and made that available in Microsoft Excel. So what I've shown you here is some of the key features, the ability to work with the different types of data of any volume, especially the data that many businesses have already got in Amazon S3, how to connect to different job flows, how to prepare your data for an analysis, how to iterate through the analysis, and then utilize those result sets in your business. Moving forward, what Amazon and Karmasphere wants to do for participants on this webinar was to enable you to get started very quickly. We're very big believers in the power of the cloud. We've got thousands of data professionals using our products, and what we wanted to do in combination was to allow participants on this webinar to get access to a free $100 Amazon Web Services credit and use that in conjunction with a fully fledged 30-day trial of Karmasphere Analyst. For anybody who's interested in following up, wants to explore and experiment with what they've seen today, I would encourage you to send email to the address that's here on the screen. And by all means, contact us with questions. And at this point, I'm going to hand back to Adam, and I think we're going to take some questions.
Yeah, one thing to add to that, please, anyone who has questions for us, feel free to send them in, and we'll answer them live here in the last 15 minutes of the webinar. Also, the email that's listed there, we're going to be showing this video after this presentation is finished and allowing other people to email in and participate. But all those who attended this webinar will be receiving that $100 credit and the Karmasphere trial. We'll be reaching out directly to you. So first question on here that we've received, what technology stack is behind the Karmasphere UI? Do you use HTML, CSS, JavaScript, Java?
Okay, good. That's a good question. So it's 100% Java application. So we've got a technology stack that, as I mentioned, from the ground up has been built for not just Hadoop, but for integration with Amazon. So at the lowest level, we know how to talk to all the different interfaces to get access to Amazon. There's a lot of core Hadoop and Hive technology that's incorporated within Karmasphere Analyst, and then a whole bunch of user interface, sort of data wrangling, and what I demonstrated today, all the sort of technology that brings that value and usability into the power of that graphical interface.
Excellent. So a question here is about Karmasphere Studio. So maybe you can talk a little bit about what Karmasphere Studio is. It asks, does it integrate directly with Karmasphere Analyst, and can you use it with Amazon Elastic MapReduce?
Yes, that wasn't the focus of today's webinar, but I did mention that as a company, Karmasphere is focused on the full spectrum of data professionals, from developers through data analysts up to business analysts. Our Karmasphere Studio product runs within the two popular IDEs, and in particular in Eclipse. It is fully integrated and has been for the last 2 years with Amazon Elastic MapReduce. And just to talk for a few seconds about that, that is really focused on developers who want to create algorithms that run on Elastic MapReduce in Java or in streaming languages, or in many cases we find teams of analysts who are using the Karmasphere Analyst product to come up with insights that they then want to operationalize, and they want to create fully optimized implementations of those algorithms in a language such as Java, and they can do that within Karmasphere Studio. You can share configurations between the Karmasphere Studio and Karmasphere Analyst product, and you can even create user-defined functions that would extend and do extend the power of Karmasphere Analyst using Karmasphere Studio. So yes, in summary, Karmasphere Studio is tightly integrated like Analyst with the Amazon Elastic MapReduce. Yes, there is integration between Karmasphere Studio and Karmasphere Analyst.
Excellent. So another question here on connecting Karmasphere Analyst to currently running Elastic MapReduce clusters. Is that possible, and how would you do that?
Yes, I might have gone a little bit too quickly through that particular stage of the demonstration, but if you recall when I was showing how you enter your Amazon credentials, once the product knows the Amazon credentials, what it does is communicate with Amazon Elastic MapReduce and enumerates any and all job flows that are running in the context of that account, and then shows them in the connection pane. So if you've got 1, 2, 3, 5, 10 clusters or job flows, as they're called on Elastic MapReduce, that are already running, those will show up automatically as soon as you put in your Amazon account credentials into the product, and every time you run the product up thereafter. Because we find many companies who run persistent clusters as their main analytics warehouse, if you like, and many companies that will run both persistent clusters and on-demand clusters, and the analyst product allows you to connect not just to existing clusters or job flows, but to run up new ones as well.
Another question for you, Martin. Does Karmasphere Analyst allow encryption of data? Also, I'm interested in compression. Can you tell us a bit more about it?
The encryption, I would have to understand a little bit more about that question, and I would encourage whoever asked that question to contact us directly. On compression, compression is a very, very big deal for people who are working with big data. Wherever possible, they want to make sure that, weblogs, for example, a lot of the time you, Adam, and we see customers who've got weblogs that are compressed. And so the support for different compression formats is very, very important for people working with big data. So whether it's gzip, bzip, LZO, we support all of those compression formats out of the box. And when I was showing the assemble stage, being able to point to different compression formats and for the product's ability to uncompress that data and look into the data is what enables a lot of the power of the product, given the number of people who do use compressed data in the big data world.
Question: can we build our own applications on top of Karmasphere Analyst? Do you want to analyze, get the results, and allow the result within our UI?
Yeah, the answer to that probably requires a little more elaboration of the question. This is a native Java application that runs on the desktop. We have a number of interfaces within the product. We'd be happy to talk to whoever asked that question in particular. But clearly what a lot of people are looking to do is to use the product to generate their insights and then be able to operationalize those things. And that's absolutely what Karmasphere is all about, enabling that kind of operationalization, that interfacing of other applications to the data and our products and our technology. So for more specifics, I'd encourage whoever asked that question to contact us, and we'd be happy to have the dialogue.
Here's a question asking if this video is going to be available after the fact. It said there's other people in the company who'd like to view it. And the answer is yes. We're going to have this up in our AWS Viewer. You'll be able to search through and look at this and any other previous Elastic MapReduce webinars and videos. And I also believe that Karmasphere will be putting this up on their website as well. And next question on here, ask about the use of multiple clusters at once within Karmasphere and sharing data across those.
I'm presuming that that's talking about multiple Amazon Elastic MapReduce clusters or job flows. So yes, absolutely. This product supports the ability to have multiple accounts entered, whether they're regular AWS accounts or IAM credentials. It also supports the ability to have whatever number of clusters running in the context of that account be available to you from within Karmasphere Analyst, and for you to start a connection to one or more of those job flows. So yes, in short.
Excellent. So that is all the questions that we have. I want to thank everyone for joining us. And as I said, we'll be posting this after the fact. And please feel free to reach out to the email if you have any further questions. And I'm going to pass this on to Katrina to close it off.
Great. Thanks, Adam. That wraps up today's presentation. So thank you to Adam and Martin, and thank you to everyone for attending today's webinar. Those who attended today's webinar will receive a follow-up email with a link of this recording and presentation. And I encourage attendees to periodically check the webinar section of AWS.com to see listings of upcoming webinars and other virtual events. So thanks to everyone, and on behalf of Amazon Web Services and our presenters, we thank you for joining us today. Bye.